Today, we will discuss about determination of size of starch grains and calcium oxalate crystal by eyepiece micrometer method. So in this session, we will discuss how to determine uh, the size of starch grain and calcium oxalate crystals by using eyepiece micrometer. But before that, we will learn a theoretical part, what is a starch grain, and we will study about calcium oxalate crystals. And then we will move further for the procedure to determine the size of the starch grain. So let us start the session. So intellectual skills, that after completion of this topic, you will understand the concept of calcium oxalate crystals or a starch grain. So you will understand what are calcium oxalate crystals or where the starch grains are present. Then you will understand details about the starch grains. Then you will able to understand the experimental procedure for determination of size of starch or calcium oxalate crystals, and you will able to calibrate eyepiece micrometer. Okay, all these points you will able to study and understand after completion of this topic. Now let us move ahead for the motor skill. So after completion of this topic, you will able to identify the stomata. Okay, so after completion of this topic, in case of the motor skills, you will able to identify the starch grains. You will able to identify a calcium oxalate crystals by observation under microscope. Okay, then you will able to differentiate between different types of the calcium oxalate crystal as well as the starch grain. Okay, so you will learn all these things after completion of this topic. Now next part is requirements. So requirements like crude drugs are required or glycerin water is required. Now crude drugs, the drug which consists of the calcium oxalate crystal or the part of that drug which consists of the calcium oxalate crystal, or you can use a starch for starch powders like maize starch or wheat starch or any other type of the starch. Okay, so you can use any crude drug which is suitable for the experiment. That is why I have not mentioned the detail. Then glycerin water is required. Then in case of glassware, especially eyepiece and stage micrometers are required, and slides are required. Now in equipment, compound microscope with mechanical stage is required because we need to calibrate the eyepiece micrometer. This mechanical stage plays very important role. Now let us start discussing about the theoretical aspects of this experiment, which are very important. Okay, now starch is present in different parts of the plant in the form of granules of varying size. Okay, now it is available or it is present in different parts of the plant in the form of granules. Okay, now the starch, it is found in the fruit, or it is found in the seed or root, rhizome, and as smaller grains in chlorophyll containing tissues of the plant such as leaf. So starch is almost found in all parts of the or organs of the plant. Okay, now the fruit, seed, root, rhizome, etc., these all are the parts of the plant, and in which you will find a presence of the starch grain, as well as it is present in the chlorophyll containing tissues like leaf. Okay, so chlorophyll is present in the leaf, as well as chlorophyll is present in a few stems also. So where chlorophyll is present, in that case there is a presence of starch grains. Now, the starches of different origin can be identified by studying their size, shape, and structure, as well as position of the hilum and striations. Okay. Now, to identify a different starch depending upon the origin, because obviously the starch obtained from maize is different in shape and size and structure than the uh, starch obtained from the wheat or potato. Okay, so obviously there will be difference between their sizes, shapes, and structures, as well as position of the hilum and striations. Okay, so to study or identify, you need to study individual structures. Now observe this image which is shown on your screen. Now these images are, for example, first image is structure of a glucose. It is a monosaccharide. Okay, so this is single unit disaccharide, sucrose, in which two units are present and joined by this linkage. Okay, so it is called as a disaccharide. Now monosaccharide, that means a single unit of the sugar is present. In disaccharide, two molecules or two sugars are present. Okay, now starch is an example of polysaccharide. So you will see more than two uh, units of the monosaccharide are present. Okay, so here you will see 1, 2, 3, 4 units. Okay, so like that the structure is made, and that structure is called as polysaccharide. So this is an example of amylose starch. So you will find different monosaccharides are the number is more in case of the polysaccharide, and that is why the word poly, that means many starch contain, or starch contain many monosaccharide units. Okay, now again the theory part of the starch, that chemically starch are the polysaccharide containing amylopectin and beta amylose. So starch is made up of two important polysaccharide, or the starch are the polysaccharide containing amylopectin and amylose. Okay, now these are the units, these dot dot. Okay, these are the small units. Single circle indicates single sugar. Okay, so those are alpha 1,4 glycosidic bonds. Okay, so the bonds are given, the arrow is given here, so the bonds are formed in between them. Okay, so the amylopectin, it is branched chain. Okay, and it is having a larger in length. Okay, then amylose, you will see alpha 1 for glycosidic linkages or bonds are present. O indicates single glucose unit. Okay, so O, that means a single unit. So this is the structure, basic structure of the starch. So these linkages are joined together, that is amylose and amylopectin, and the ratio of that, that means amylopectin 30 as to 70 or 20 as to 80, with amylopectin found in larger amounts than the amylose. Okay, so 30 70, that means the amylopectin is 70 and 80, and amylose is present in the smaller amounts. Okay, so 30-70 ratio or 20-80 ratio for the amylose to amylopectin. That means amylopectin is available in the larger amount than the amylose. Now the amylose chain can be made up of several thousand glucose molecules. Now this amylose, so it is made up of several thousand molecules. So imagine it is very long structure, and the chains are curved and result in a coiled helical structure like a spring. Now this is like a spring structure. You can see in this picture, the spring-like structure is present. Okay, so that structure gives appearance like a helical structure, or it appears like a spring. And amylopectin, very similar to amylose, but chains are shorter and side branches are present. Now here you can see this is a side branch, but in this case a side branch is not present. So in case of amylose, side branch is not present, while in this case amylopectin you will see these branches. So amylopectin, it is not a spring like or helical structure, but the side branches are there. But in case of amylose, a long 1,000 glucose molecule or more than 1,000 molecules are present, and it is a straight line chain, so it appears like a helical structure or spring like structure. So this is a basic chemistry of starches. So starches are nothing but the polysaccharide compound, and their major constituent include amylopectin and amylose. Now, in this figure, you will see a chemical test for identification. So this is identified with the help of iodine solution. So peel potato, add iodine to it, and iodine turns blue black if starch is present. So this is very simple test. So if a starch is present in given compound, it will shows blue to violet color when it is treated with the iodine solution. Now the starches which are required in a pharmaceutical purpose or pharmaceutical interest, these are obtained from maize, rice, wheat, and potato. Majorly, these are the sources of the starches, because the starch is required in various pharmaceutical methods, like it is used in a formulation of a tablet. Okay, it is used in many uh, formulations related to the powders also. To increase the bulk, starches can be used. Okay, so the starches are obtained from the maize, rice, wheat, and potato, and these starches can be differentiated from each other by microscopical examination. Okay, and for microscopical examination, the powder should be mounted in Smith starch reagent containing equal parts of glycerin, water, and acetic acid. So for this purpose, first you need to mount starch in Smith's starch reagent, which is also called as glycerin, water, and acetic acid, that is a 50%. Now on your screen, this is a basic types of the starches obtained from the different sources. So let us discuss one by one. Part figure A, that is a maize starch. Okay, maize means you know very well that sweet corn or corn starch. ठीक आहे, मक्याच्या कणसापासून जे असतं ते maize starch. So their granules, you will see round or polyhedral, diameter range from 5 to 35 micrometer. Okay, so here you can see a polyhedral or round shape granules are present. Hilum, that means the point of attachment. This point of attachment, now this is hilum. Distinct central triangular striations absent. Okay, as compared to that, in case of this D, potato starch, you will see hilum here. At this point hilum is present, and these are the striations you will see. Okay, then the other starches are shown here. Figure B, it is rice starch. So these starches having a smaller or these starches are smaller in size as compared to the A, that means maize starch. Okay. Then type D is potato starch. So the size is larger than all mentioned starches here. So it is a larger in size, like 30 to 100 micrometer, and a well marked striations are there. Here you can see faintly marked striations are there, and the size of this wheat starch is 5 to 50 micrometer. So the different shapes are available. For example, now this maize starch is round or polyhedral shape, while rice starch polyhedral in shape, then wheat starch lenticular, circular, or oval in shape, and potato starch is simple, irregularly spherical and subspherical shape. So this is a characteristic features of the starches. Now, why I have shown in this experiment? Because you need to determine the size of the starches. But first of all, you should know how the starches appears. Now, the sample can be given, a different sample can be given to you during examination. So that is why you should know the characteristic of the different starches. Therefore, I have shown these characteristic feature of the starches slide here. Okay. So this is about the starches. Starches available in different size, their characteristic are different, and their shape appearance is also different. Now the second part, that is a calcium oxalate crystals. Now again in this figure you will see solitary crystals in the different shapes are given. For example, one solitary crystals. Now these are the crystals. This is figure 1, which is present in allium. Okay, that means garlic. Then sparpaphides in a nerium leaf. This is example of sparpaphide or pharaphides. Okay. Then third, raphides. Okay. So the calcium oxalate crystals are also present in different size and different shapes in different types of the plants, and it become their identification characters. Okay. So individual plant can be identified with the help of a calcium oxalate crystal. So it helps in diagnostic, or it helps in the evaluation of crude drugs, and therefore it is very important to understand about the calcium oxalate crystal. Now calcium oxalate crystals are distributed among all taxonomic levels of photosynthetic organism, from small algae to angiosperms and giant gymnosperms. Okay. So calcium oxalate crystals are distributed among all taxonomic levels of photosynthetic organism. So it is present among almost all levels of the photosynthetic organism. So that word is important, photosynthetic. So the plants which have ability to synthesize their own food, in those only calcium oxalate crystals are present. Now, the accumulation of crystal by these organisms can be substantial. Now, why calcium oxalate crystals form, or why formation of calcium oxalate crystals takes place in plants? Because a high capacity calcium regulation is required, because it may cause stress in the plant. Therefore, the calcium levels shall be maintained, and that are maintained with the help of formation of calcium oxalate crystals. Okay. So free calcium, if present, it may lead to the stress on in the leaves or in the plants. So to avoid that and to minimize large levels of the calcium, plants are converting that calcium into the oxalate crystal, and with the help of that if calcium oxalate crystals are formed, it will give or it provides protection against the herbivores. Okay, so to provide protection, normally calcium oxalate crystals are formed in the plant. Now, in this experiment, what we want to do, we have to determine their sizes. Okay, so now I will show in this figure, you will know, that the standard diameter for maize starch is 5 to 35 micrometer. Then wheat starch 5 to 50 micrometer. Then 30 to 100 micrometer size is for potato starch. So these are the standard diameters. So if you want to evaluate the product, the size of the starch also lies within the limit, or it should lie within the limit, and therefore it is necessary to determine their size. Okay, so how will you determine? It will be determined with the help of eyepiece micrometer and with the stage micrometer. How? Now let us discuss that. Now for the starches, the simple method is given because you need to prepare a slide. Okay, on microscopic slide, you have to just take a pinch of powder in case of the starch, apply iodine and observe under microscope. Then the microscopic observation will show presence of starch in a blue color. But in case of calcium oxalate crystal, first you should clear the sections of the drug with caustic alkali or chloral hydrate. Now remember that starch grain you can determine within a powder, or also you can determine in sections, but the best way is to determine within a powder. That means directly maize starch or prepare the wheat starch and directly measure the size. But in case of calcium oxalate crystal, it is very difficult to isolate oxalate crystals, and therefore you need to take a TS, and in that TS, first to determine calcium oxalate crystal, treat that with a caustic alkali or chloral hydrate to clear, okay, these compounds, caustic alkali and chloral hydrate. These are used as a clearing reagents. Okay, now these clearing reagents will clear unwanted impurities in the product. Okay, therefore the first step, take the section, then interact or add caustic alkali or chloral hydrate to that. Then these reagent very slowly dissolve the crystals. Okay, so the observation should be made immediately after clearing the section. Obviously these are the clearing reagents, so they may have effect on the calcium oxalate crystal also. So after addition of this reagent, you should observe immediately. Okay, and the polarizing light or polarizing microscope is useful in the detection of small crystal, and therefore these are the important things in determination of the calcium oxalate crystal. Now mount the cleared section or powder in the following reagent. Okay, now you can use many solutions to identify that. That means first clear the section with a clearing reagent, and second to that you can add acetic acid to find the difference. So if calcium oxalate crystals are present, it will not dissolve in the acetic acid. Then if you add caustic alkali, those are also insoluble. That means in caustic alkali the starch grains are not soluble. But if you add hydrochloric acid or sulfuric acid, the calcium oxalate crystals will get solubilized. So you will able to make a difference, or you will able to differentiate whether you observe whatever you have observed is calcium oxalate crystal or not. That means first add clearing reagent and observe calcium oxalate crystals will appear, but as soon as you add hydrochloric acid, those will disappear. That means you will learn that which crystals get solubilized, and depending on that you will able to identify the calcium oxalate crystals. Okay, now let us discuss the procedure. Now that procedure is part of a section preparation. Okay, you need that section for observation. Now this part, that is a calibration of eyepiece micrometer with the help of stage micrometer. I have shown both eyepiece micrometer here and the stage micrometer here. Okay, now both have a small scale on that. So you will see here, this is stage micrometer. That means this is a slide like this, and on that scale is engraved. Okay, so you will see a minute scale is there on that slide. In case of this is a part of a eyepiece which is there in the microscope, and on that a scale is there. So you can see here a scale is shown. Okay, so here you will see a scale. Okay, so this is the scale. Now both eyepiece micrometer and stage micrometer have scale. So the stage micrometer scale is shown here with these lines. Total 100 divisions are there. Even in case of eyepiece micrometer, 0 to 100 divisions are there. Okay. So if you observe under microscope, the scale will appear like this. Okay. Now, next step, how to calibrate eyepiece micrometer with the help of stage micrometer. So the procedure is that take the micrometer slide in hand and feel the sides of the slide. The correct side shows a slight elevation on the one side. So it is just instruction. So you have to keep printed side on the upper side. Okay, so slide, don't keep that printed side on the below of the stage micrometer on the stage. So just keep at upper side. That reading should be on upper side. Then place it on a stage micrometer and view the scale through the eyepiece at 10 by 10 magnification to find the position of the scale on the microscope. And then you can locate the scale. That means first thing, you have to just take the micrometer slide. That means stage micrometer slide, and then observe under the microscope with 10 eyepiece size and 10 objective size. So with 100x power. Okay. Now eyepiece micrometer. Now remove the eyepiece and unscrew the part A. Now eyepiece micrometer is available. So you can directly take eyepiece micrometer and place over the that tube of the microscope, and first of all you have to remove the original eyepiece of eyepiece of the microscope and keep eyepiece micrometer onto that. Okay, now you will see both slides. Now in case of the calibration, you will see first this is a reading of the stage micrometer, because in the first step we have focused stage micrometer. Okay, see, this is a eyepiece micrometer. Image A is eyepiece micrometer, then image B is stage micrometer. Now both images are visible to you. Now you can rotate eyepiece micrometer. So what you have to do in the third step, that superimpose ocular microscope over stage micrometer. Okay, now this is a reading of an ocular microscope. So you have to move the eyepiece micrometer and superimpose over the reading of the stage micrometer. Okay, so simple thing, you have to just superimpose both eyepiece micrometer reading over the stage micrometer reading, and then measurement of a size of the microorganism or the starch grain. Okay, now this is very simple thing. So what you have to do, take stage micrometer slide, adjust it, and to that add eyepiece micrometer slide. Now you have to observe that how many lines are coinciding with each other. So see, for example, first line is exactly coinciding with each other. Then find which is another line of stage micrometer and eyepiece micrometer is exactly superimposing or exact over it. Okay, observe for that. So for example, two lines of the eyepiece micrometer is equal to the 5 lines of the stage micrometer. It is a very simple thing. Okay, so 2 divisions of the eyepiece micrometer is equal to 5 division. Why? Because we have compared that the first line which is coinciding with one and the second line which is coinciding exactly with the other reading. So in between how many divisions are present, just calculate that. म्हणजे पहिली लाईन जी तिथं कोइन्साइड होतीये त्याच्या सोबतच दुसरी कुठली लाईन एक्झॅक्ट एकावरती एक मॅच होतीये ती बघायची आणि त्याच्या मधल्या डिव्हिजन आहेत त्या काउंट करायच्या. सो 2 divisions of eyepiece is equal to 5 division of the stage micrometer. So now you have to calibrate the stage micrometer, sorry, eyepiece micrometer. You will see 2 divisions of eyepiece is equivalent to 50 micrometer because the size of each division is 10 micrometer. So now you can easily calculate by using this formula. If 2 divisions is equal to 15 micrometer, so 1 division is equal to x. So x is equal to actually 50 divided by 2. That will be your formula. Okay, so x is equal to 50 divided by 2. So that 25 is your calibration factor and it is required for further studies. So calibration factor is required. Now the stage micrometer, you will see 100 divisions are there and 1 mm is equal to 1000 micrometer. Okay, 1000 micrometer. So each division, what is the value of 1 division? Because 1 mm consists of the 100 division. Okay, so what is the value of 1 division? So x is equal to 1 divided by 100. So that is around 0.01. That is a value of 1 division. And if you multiplied it by 10, so 100, you will get 10 micrometer. Okay, so the value of 1 division is 10 micrometer. Okay, now this procedure already we have studied. So calibrate the eyepiece micrometer. Now after calibration, remove the stage micrometer, and then prepare the slide, keep it on a stage, and observe the length and breadth of 25 starch grains or calcium oxalate crystals. Multiply the values by the factor and calculate the average value, and try to cover or try to match that with the values observed in a standard one. Okay, so this is experiment. 1 minute is remaining. If meeting ends, rejoin it. Okay, so within a minute our meeting will end, so rejoin, because we have a further formality. Okay, I will take only 10 minutes after this break.